Okay, in part one, I tried to give you the background and some terminology and get you used to what was going on. Now for part two, let's actually do some calculations where we actually find some confidence intervals. Remember, here's our formula. To use this formula, the numbers we have to plug in are x bar is our sample mean, sigma is our standard deviation, n is the sample size, and z sub alpha over 2 depends on the confidence level. And the most common confidence levels are either 90, 95, or 99%. So this little chart here shows you what numbers we'll be using for z sub alpha over 2 for those particular confidence levels. There is also a graphing calculator function that you can use. If you have a graphing calculator, it will give you the confidence interval. So I'll show you how that works in a couple of these examples too. So let's say we want to find the 99% confidence interval for the population mean if you have a sample of size 49 whose mean is 312 if the population standard deviation is 13. Okay, so X bar is the mean for the sample, and they told us that that is 312. Sigma is the population standard deviation. They told us that is 13. N stands for the sample size. They told us that is 49. And for a 99% confidence interval, the number we use for z sub alpha over 2 is 2.58. So when we plug those numbers into the formula for the confidence interval, here's what it looks like. 312 minus 2.58 times 13 over the square root of 49 is less than mu, is less than 312 plus 2.58 times the square root of 13 over, or times 13 over the square root of 49. Okay, let's put this into the calculator. I should be able to just type this in pretty much the way it appears here. 312 minus 2.58, and I don't really need the parentheses. You can put them in if you want, or you can leave, or you can just say times, but times 13 divided by the square root of 49, and if you did put the parentheses in, we can close them, and it gave me 307.2 approximately. By the way, if you're doing this yourself, remember the order of operations. The subtraction comes last after the multiplication and division here. So it's 312 minus the result of this other calculation. And because the calculator knows about the order of operations, it will do that in the correct order. So it's 312 minus this, which gives you about 307. Now the other half of the formula is exactly the same, but with a plus instead of a minus. So if you have the kind of calculator that lets you move up and edit your entry, or recopy it and go back in and change it, all we have to do is change that minus to a plus. And this time it's 316.79 something. So depending on how many decimal places you want to give in your answer, rounded to the nearest whole number, you would say it's 307 to 317. Or rounded to one place after the decimal point to the nearest tenth, you could say it's 307.2 to 316.8. So basically, this is saying that under the circumstances, we can be 99% confident that the true population mean is somewhere between 307.2 and 316.8. Now, if you have a graphing calculator, it does have a special built-in function that will calculate confidence intervals like this for you. To get to that, push the Stat button and use the arrow buttons to go over and highlight Tests and select Z-interval. Now, you should highlight Stats instead of Data, and it has slots for you to put in sigma, that's 13 in this example, and then X bar is 312, and N is 49, and the confidence level is 99%, so we put that in as 0.99. Then go down to calculate, hit enter, and there's the interval, 307.2 to 316.8 if you round to one place after the decimal, or one decimal digit. Let's try another example. To estimate the mean age of students at a college, a random sample of 40 students is taken, and their mean age is 20.8 years. It is known from previous studies that sigma equals 2.3 years. Find the 95% confidence interval for the population mean. So there are four numbers we need. We need X bar, which is the sample mean, and that is 20.8. Their mean age is 20.8 years. Sigma is 2.3 years. N is the sample size, how many students were in the sample, and that's 40. If it helps, N is always going to be a whole number. And then we want a 95% confidence interval, so the number we're using for Z sub alpha over 2 is 1.96. Now, when we put all that into the formula, here's what it looks like. And when I put that into my calculator, 20.8 minus 1.96 times, this time I'm not going to use the parentheses, you don't have to have them, times 2.3 divided by the square root of 40 is, or about 20.1. And then the same thing, but with a plus instead of a minus, is 21.5. So the interval is from 20.1 to 21.5. In other words, that means that we can be 95% sure that the average age of all the students at this college is somewhere between 20.1 and 21.5 years old. Next example, noise levels at various urban hospitals were measured in decibels. The mean of the noise levels in 84 corridors was 61.2 decibels, and the standard deviation of the population was 7.9. Find the 95% confidence interval of the true mean. So we need the sample mean X bar, we need the population standard deviation sigma, we need the sample size N, and we need the number for Z sub alpha over 2. So the sample mean is 61.2. The mean of the noise levels in those 84 corridors was 61.2 decibels. Sigma is 7.9. The standard deviation of the population was 7.9. N is 84. That's how many corridors were included in the sample. That's the sample size. And for a 95% confidence interval, Z sub alpha over 2 is 1.96. So put that all into the formula. And 61.2 minus 1.96 times 7.9 divided by the square root of 84 is about 59.5. And then the same formula, but with a plus instead of a minus, is about 62.9. So the answer is that mu is probably somewhere between 59.5 and 62.9. 59.5 is less than mu is less than 62.9. The other topic that we're talking about in section 7.1 is sample size. How big does the sample have to be? So I will save that for the next video. See you then.